Good afternoon, everyone. We are just waiting for the participants to join. So we'll start in 5 minutes or so. We are just waiting for more participants to join. So please bear with us. We will start soon.
ये लिखा ना वो स्क्रीन दिखाओ क्या कर रहा है तू यहाँ से करें तो
ये शैलेश sir, we should start.
चलो फिर ठीक है कर दें शुरू
100 participants. Yes.
so I think we should start now. Okay. So hello and welcome to all the participants. Namaskar. My name is Shailesh Agrawal and I on behalf of Ministry of Housing and Urban Affairs, Government of India and Building Materials and Technology Promotion Council, GIZ, and on my personal behalf extend a very warm greetings and welcome you all in this fourth webinar on Lighthouse Project, which is being held today on LHP site at Ranchi. Unfortunately, our Mission Director and Joint Secretary Housing for All, Shri Kuldeep Narayan Ji, is engaged with the Indo-Russian meeting, and if he gets free, he will join and give his opening remarks. But let me welcome other officers from the ministry, PMU team, and GIZ team. I also welcome state level nodal agency SLNA, their officers and their SLTC and CLTC team, including officers, engineers, and architects of other state level agencies. I also extend a very warm welcome to the representatives of technology provider, including the construction agency personals, to this webinar. As you know, today we are holding this webinar at Ranchi, which is one of the LHP site under GHEC India. And through this webinar, our efforts will be to make you all comprehend the innovative construction system being used in this project. This is the most advanced technology which is being implemented in Lighthouse project at Ranchi, and we will also be taking a virtual tour of Ranchi site. The participants here not only include TECHNOGRAHIS who registered through online enrollment drive initiated by HFA Directorate, but also we have engineers, architects, planners, professionals, faculty, members, developers, technology providers, and students from engineering and architecture colleges of Jharkhand state as well as from other parts of the country. The overall objective of this webinar is to educate all of you about the new construction systems which are being used in the project, and also build capacities within India so that you can, in your future endeavors, you can replicate, you can implement and make use of this information which we'll be sharing with you. We would also be, making you aware about the initiatives taken by Government of India to introduce innovative emerging construction systems in the construction sector. These innovative construction systems are resource efficient, climate responsive, disaster resilient, and energy efficient, which is the need of the hour. So we have to change the way we construct by introducing these systems, which are resource efficient, climate responsive, disaster resilient, and energy efficient. Also, these systems which we are sharing with you impart speed to the construction activity and help deliver superior affordable housing and infrastructure, which is better in terms of structural and functional performance. Also, quality and durability than the conventional cast in situ RCC frame construction. All of you might have heard, a week back there was a news item in the newspaper that L&T, in association with DRDO, that is Defense Research Organization, they, built a 130 lakh square foot space. That is a 7-story building in Bangalore in 45 days. And the technology used by L&T and DRDO was the technology which we'll be introducing with you. They used hybrid technology with precast concrete construction. Just to give you overview, these innovative construction systems are being showcased through 6 lighthouse projects, which are being constructed in 6 places, namely Rajkot, Chennai, Indore, Lucknow, Agartala, and Ranchi. At all these 6 lighthouse projects, 6 distinctive innovative technologies are being used, and we will be holding these webinars at all these 6 places for participants to understand the implementation issues related with these technologies. So far, we conducted 3 webinars, namely at Rajkot, Indore, and Lucknow. There will be around 40 webinars till November 2022. During the webinar, we will also be taking you to the virtual tour of LHP site at Ranchi to take stock of the present construction activities. And if possible, we'll also show you the actual installation of 3D volumetric construction. It is a unique opportunity. I always repeat this, that this is a unique opportunity where we will explain you theory as well as give you the field exposure. I sincerely hope that you all will get benefited by this webinar and learn new things which will be implemented by all of you in your future projects. Before I get into the technical details, I also welcome Gautam ji, who is the director HFA5 to this webinar, because I see him now. And now I will request Manish to run a short film for the LHP at Ranchi, after which we will start the technical lecture. Manish, if you could share your screen with LHP.
Is the screen visible? Sir, is the screen visible to you?
Yeah, it is coming blank. Yeah, it has come. Come.
Right.
Yes. शुरू से चला दो एक बार.
Ministry.
Yeah. Increase sound.
Housing and Urban Affairs, Government of India has initiated Global Housing Technology Challenge India to identify and mainstream best available global technologies so as to bring paradigm shift in the construction sector. 54 innovative technologies put in 6 broad categories were shortlisted during the challenge process. 6 lighthouse projects at 6 locations with 6 distinct technologies are being constructed. Lighthouse project using precast concrete construction system 3D volumetric with 1008 dwelling units in G+8 configurations. Along with all basic and social infrastructure facilities is being constructed at Ranchi in partnership with State Government of Jharkhand. Honorable Prime Minister laid the foundation stones of 6 lighthouse projects, including at Ranchi on 1st January 2021.
आज गरीबों के लिए, मध्यम वर्ग के लिए, घर बनाने के लिए नई टेक्नोलॉजी देश को मिल रही है। ये 6 लाइट हाउस प्रोजेक्ट देश में हाउसिंग कंस्ट्रक्शन को नई दिशा दिखाएंगे। रांची में जर्मनी के 3D कंस्ट्रक्शन सिस्टम से घर बनाएंगे। इसमें हर कमरा अलग से बनेगा और फिर पूरे स्ट्रक्चर को वैसे ही जोड़ा जाएगा जैसे
मोदी आज
लेगो
तक
ब्लॉक
से नहीं कर
Due to ground level issues, the actual construction work of LHP Ranchi could start only in August 2021. The construction work of this project is now in full swing. This 3D volumetric construction system is being used first time in construction of houses under PMAYU. In this fast track system, solid precast structural module like room, toilet, kitchen, bathroom, stairs, etc. are being cast monolithically in casting yard at site in controlled conditions. In this modern system, construction begins with keeping the design foundation of the building ready while manufacturing of precast concrete structural modules is taking place in the casting yard. Finished rooms, toilet, kitchen, bathroom are then installed at the site with the help of tower cranes. Cable and walls are positioned to terminate the sides of building. Pre-stressed slabs are then installed as flooring elements. Rebar mesh is placed for structural screen, thereby connecting all the elements together. Consecutive floors are then built in similar manner to complete the structure. About 90% of building work, including finishing work, is completed in the casting yard, which saves overall construction time. Casting yard adjacent to the construction site in Ranchi with all facilities is now functional and is being used for the production of preset 3D and other components. While casting yard facilities was being established, raft foundation for all 7 towers were initiated, which are now at different stages of construction. Once foundation work up to grid slab is completed in a tower, preset 3D components getting ready in casting yard will be installed at the site to complete the tower. With all these parallel activities, the project is progressing well and is expected to be completed well within stipulated time. There is tremendous response for booking these houses by beneficiaries. The LHP Ranchi is serving as live laboratory for learning. About 200 technograhis and other stakeholders have visited the site to learn the use of innovative technology in real project at site.
Thank you, Manish. Thank you, Manish. So this was the film about the lighthouse project at Ranchi, and after the technical lecture, we'll be taking you through this the Ranchi site, and if possible, we will also show
पता नहीं
you
मुझे
the
क्या हुआ
casting
है
yard.
इस कैमरा से जितना जुड़ा हुआ सब हम सर्च कर रहा है
Please, humbly, I request everyone to mute your respective mics so that you. So with this, let me start my first lecture. First, we will try to explain you the 54 new construction systems which have been shortlisted by Ministry of Housing and Urban Affairs through Global Housing Technology Challenge, and the categories, those 6 categories, I'll explain you quickly. And after that, we will get into the project, LHP project at Ranchi, and discuss with you in detail the technology being used in the lighthouse project at Ranchi. Let me share my screen. Hope it is visible to everyone. If anyone can respond, it's visible. Yeah.
Yes.
So welcome again to this webinar session 4 at Lighthouse Project in Ranchi. I'm going to talk to you about the initiatives taken by Government of India, Ministry of Housing and Urban Affairs through Global Housing Technology Challenge, through which we identified 54 new technologies divided into 6 categories. So I will first explain you all those 6 broad categories pictorially in a very simple thing. This is just to give you the progress of Pradhan Mantri Awas Yojana. Most of you might be aware, we're working in SLTC ONGC, CLTC, and other, SLNA, you know that the sanctioned houses are now more than 1.2 crores, out of which 95 lakhs have already been grounded and 56 lakh have already been completed and delivered. And this, believe me, this figure is changing dynamically very fast. This also through PMAY, we are able to generate direct and indirect employment to the tune of 2.33 crores, and overall cement consumption and steel consumption is also in million tons. Also, 16 lakh houses, because we are running a technology submission under Pradhan Mantri Awas Yojana, through which new construction systems, alternate ways of construction, energy efficient, eco-friendly building materials and techniques are also being promoted in various states, and through that technology mission we could construct, or we are constructing 16 lakh houses using these new technologies, which I'm going to discuss with you. This all started with Global Housing Technology Challenge, which was organized in March 2019, 2nd and 3rd March. The Global Housing Technology Challenge was inaugurated by Honorable Prime Minister, and during this Global Housing Technology Challenge, we did organize a big conference come expo where more than 100 global technology providers participated and showcased their various innovative construction system. And you might find a word here, challenge. So the challenge thrown to the word was to share with us the technologies, construction systems, which can help build maximum number of houses in minimum time and minimum cost. So challenge was maximum number of houses in minimum time and in minimum cost. Do we have that kind of technology or construction system? And let me share with you that we could identify through the Global Housing Technology Challenge 54 new construction systems, which are divided into these six broad categories. And I will definitely explain you all these 6 technologies through pictures. And right now, these 6 broad categories are being showcased at these 6 lighthouse project sites. So this is the basket of 54 technologies, depending upon your project requirement and depending upon the time and cost. The finance is available, you can choose any one of these technologies suiting to your requirement. And another point I want to make here, that while shortlisting these technologies, the technical evaluation committee was formed, which comprises of DGCPWD as its chairman, and the persons from academic institution, research institution, PSUs, and other organizations. And that committee shortlisted these 54 new technologies. Also, these technologies have already been approved not only by Ministry of Housing and Urban Affairs, but also by CPWD. And for most of these construction systems, CPWD has also published the schedule of rate as well as specifications. And if you're really interested in those SORs, you can visit cpwd.gov.in website and download the DSR 2019, where you can get this all SOR. This is also available on our website. All these lighthouse projects, the foundation stone was laid on 1st January 2021 virtually by Honorable Prime Minister. And while inaugurating these lighthouse projects, Honorable Prime Minister desired that these projects should be treated as live laboratories, and we need to make people understand these technologies, ask them to visit, study these technologies in detail, and later they should adapt these technologies for their future works, and also learn in the process of implementation of these technologies at LHP sites. So that is why this initiative is taken by Ministry of Housing and Urban Affairs to conduct these webinars at all the LHP sites and make you people understand about the technology. Also, we have enrollment drive in place, which is TECHNOGRAHI. So through that, by visiting the GSTC website, you can register yourself as TECHNOGRAHI and get connected with the ministry. You can also visit, I think in the later half, Manish will tell you that every 10th, 20th or 30th of every month, anyone can go to these LHP sites, and there you can get exposure to all these technologies. We have kept these 3 dates where anyone can go and visit the LHP sites and see the implementation taking place with these technologies. Now, let me tell you that what we have before we get into the emerging construction system, because I've been repeatedly telling you that what is this emerging construction system, and before that, what do we have? How do we construct our buildings? So these are the 2 systems which are in vogue or in practice or being used world over. So word over, how do we construct buildings? We construct either do a masonry construction where we make walls with brick masonry, stone masonry, and then we have a cast in situ RCC slab, and then we do plaster and all fixed windows and doors. So that is called load bearing construction. And the other, which is the most popular or omnipresent system word over, is cast in situ RCC frame construction, and which is shown in the bottommost right hand bottommost portion, the picture. And what you see here, vertical members are called columns, and then you have beams. They are cast at the site, and then the spaces in between the frame are filled with the brick wall, or it can be fly ash brick wall, or it can be AAC block or any kind of thing. So these two are the most popular system. And now we all are very well aware of that with these, if these systems are employed in the field, most of the projects, they are struggling with time overrun, cost overrun, sustainability, and there are a whole lot of other issues which I'll be talking to you in next slide. So this is the slide which shows if you continue to use these systems, first of all, these systems are slow track. So we have to fast track the construction. And for that, we require this emerging construction system. Also, in these construction systems, we are using natural resources, whether you talk about cement, you talk about all of brick makes use of top fertile soil. Then sand is again because of illegal or irrational mining or banning of mining by some states. The sand is not available, aggregates are not available, and cement is also based. Cement and steel are based on a natural resource, iron ore and limestone. So we are maximum utilizing these natural resources. So we have to put techniques, materials, and processes which are resource efficient. Can we add little bit of waste? Can we use fly ash or other cementitious, supplementary cementitious material to make concrete or cement, resource efficient? Okay. Similarly, the third is waste generation. All of you know, if you happen to visit any project site, you will find heaps of demolition, construction waste, sand, and all those things. So by employing these alternate construction system or emerging construction system, you can minimize the waste to a bare minimum. Air, land, water pollution is quite high when you will do brick by brick construction or cast in situ RCC construction, and that is the region in bigger cities when air quality index reaches a threshold, we stop the construction activities, and it is because the construction systems or techniques being deployed at present at the project sites, they are polluting not only the air but land as well as water. And through these systems, if we do the construction off-site, you can always minimize the pollution. It's labor intensive. Conventional construction, it is you're dependent on labor and weather, and we all saw during COVID time that what happened to the construction project. Most of the construction project came to standstill because of labor intensive aspect. And whereas in alternate construction system, they are in slice systems, and you can do the entire operation in the factory. So irrespective of your weather and other conditions, you can continue to produce, and that's what is happening. We will show you in Ranchi. Right now, foundation work is going on. At the same time, rooms, modules, and various structural elements are being manufactured in the casting yard, which is just adjacent to the project site at Ranchi. Similarly, in Chennai, we will show you a picture. In Chennai also, while foundation work was going on, they set up a manufacturing or casting yard, and where all the structural elements could be manufactured, could be cast and then assembled. And that is why we find the maximum progress in Chennai project. It's almost coming to an end. Then conventional construction systems are based on prescriptive design. All of you know that we use 9-inch wall, we use 4 to 6 inch. There are thumb rules, 4 to 6 inch slab. So they are based on some prescriptive design, and we use them. So making them sometimes they may not be cost economical. Whereas in alternate construction system, we have thin walls and everything is cost effective, and because since you are optimally utilizing not only the resources but also the space. And it is always said that when you are using emerging construction system, because your walls are thinner, so for the same built up area, you have more carpet area. You understand? If you have a 9-inch wall and that 9-inch wall is replaced by 120 mm wall or 4.5-inch wall, naturally you will have more space inside your house or inside your premises. And so that makes it cost effective design. better health and productivity by employing these new construction system, whereas in conventional construction system, indoor air quality is not that healthy. Conventional construction system also requires, if quality control and quality is not up to the mark, and if we don't have quality control and assurance measures at the time of construction, the projects require maintenance, because we find early signs of distress in terms of seepage, in terms of water leakage, in terms of settlements, hairline cracks, shrinkage cracks, and all that. That is why the buildings, constantly around the life of the building, they require maintenance. Whereas in this system, because these are industrialized system, the maintenance cost is quite less. Thereby, we have low life cycle costs. Energy intensive process, because whether you use cement, whether you use steel, you use brick, all of them use fossil fuel. All of these materials are based on requires some substantial amount of energy is utilized to produce these materials and products and components. Whereas here in alternate construction systems, we can put in practice the energy efficient practices. Okay, and when you do next is cast in situ and factory made component, you can understand the difference. If you do the construction at the site, we all know how water is being mixed to make concrete workable. Whereas in factory made, you have to, it's like any other manufacturing facility where, every product has to pass the quality control and quality assurance test. So similarly for building product, whatever elements you are making in the factory, they has to pass so that quality test. And once it is passed for that quality, then only it is sent to the site. So thereby, ensuring the quality of your various structural components. Greenhouse gas emission, break carbon dioxide when in a kiln, carbon dioxide is being emitted. Similarly for cement, all of us know CO2 is being emitted. So they are high on greenhouse gas emission, whereas alternate construction system are low on greenhouse gas emissions. So overall, if we have to sum it up, conventional construction system, which I showed you here, these are the conventional construction system. We will continue to use them. We will be leading towards unsustainable development. Whereas by employing these emerging construction system, we can have sustainable development. This is just an acronym which I invented, I would say. So emerging construction systems will help you build safer structure. And you can see here it is self-explanatory, safer, SAFER, and each word is self-explanatory. S stands for sustainable, which means resource. By employing these systems, you can have resource efficiency, climate resilience, environment friendliness. Affordable means cost-effective, faster construction, because you fast track the entire construction. Functional, sometimes when we talk about these in emerging construction system, the questions regarding functionality, thermal comfort and acoustics, fire resistance, water tightness, joints and connections are being questioned. But let me assure you here that as far as functional performance is concerned, these emerging construction systems offer superior performance in terms of these parameters. Economical, low life cycle cost. It's not about only the cost per square meter, but it is the cost, the maintenance cost and the disposal cost of your building once the service life is over, how the building is going to be disposed, whether it is going to be detrimental to the environment or not. That also need to be considered when you do a project or when you decide the technology. So always remember, life cycle cost has to be low or to bare minimum. And these emerging construction systems help in reducing the life cycle cost. And better quality means less maintenance, so thereby economical. Resilience is also is of foremost importance, because in our country, our the geoclimatic profile is quite complex. We have earthquakes, we have wind cyclones, we have floods, thunderstorm. So whatever we do has to be disaster resilient, and all these systems which we are talking to you, or which they provide structurally superior buildings with disaster resilience. So with this, also there was a study by the Energy Research Institute which says that by going towards sustainable development, you can considerably reduce energy use, 30 to 50%. You can reduce water. You all know potable water is being used during construction, and that water reduction can be done up to 40% by taking the construction to the factory or offsite. And it helps in improving the environment or eco-friendliness, because we considerably reduce the greenhouse gas emission, and waste reduction is up to 75%. So with this, let me explain you these six construction systems. If you remember, I will just go to that slide. These are the six systems, and I will explain you pictorially in a very simple parlance all these six technologies. So first is 3D precast volumetric construction. 3D precast volumetric construction you see here. So what you see in the right hand bottom portion, a picture which shows the conventional construction. So normally the construction takes place like this. Cast in situ RCC frame construction, and then you have bricks, door, windows. What about this? Can't we replace this by this kind of system where the entire room or entire module is made in the casting yard in the factory, and then you put one over other like you put on Lego blocks? So these are customized factory-made volumetric construction. You can have 4 walls, you can have both the floors, or you can have one floor. So depending upon the requirement you can have. So this is 3D precast volumetric construction, replacing your RCC framed beams and columns by this 3D module. Okay, or a volumetric construction. Why it is called 3D? Because it is a volumetric construction comprising of L, B, and H. Okay, so like this, you can construct the entire building, and this is what we are using in LHP Ranchi, which will be showing you in later part of the webinar. And these are the actual, the stages of 3D volumetric construction. What you have to do is, you have to prepare a reinforcement cage, then you have to have a mold, and then you insert the, I think we will show you a live demonstration. This reinforcement cage is inserted into a mold, then concreting is done, and then after that mold, it is demolded, and then it is the entire module is taken out, cured, and then transported to the site, and then over already laid. And we will show you that picture of Ranchi where we already have a great slab, and over which we have already put these 3D models. Then transported to the site, and then put them one over there. And this picture, what you show here, is a picture from our Tata project in Mumbai. So under 3D volumetric construction, we could, through Global Housing Technology Challenge, we could shortlist 4 agencies which are listed here. And the project at Ranchi is being done by Magicrete Building Solutions, who are pioneers in bringing this technology to our country, 3D modular casting using steel mold and high performance concrete. Okay. So this is the Ranchi project. Anyway, we will be going into the details of this project later. And next is the precast concrete construction. So the difference between the earlier we are making this kind of thing. So it is a volumetric construction where we have all the 4 walls, and we have a slab or without slab. So it is an enclosure, or it's a module, or it's a block. Whereas in 2D precast concrete construction, we just make 2D planar element. It can be beam, it can be column, it can be wall panel, it can be facade, it can be staircase. So all these elements, structural elements, whether it is beam, column, wall, they are made in the casting yard or in the factory, and then transported to the site, erected, assembled, and used. So that is 2D precast concrete construction. You can see these elements. So these are slab element, this is a staircase element, this is a wall panel, this is a slab solid slab, this is a hollow core slab, these are spandrel beams, these are staircases. So all these are being cast in the factory and then jointed together to create a building or whatever shape you have. So through Global Housing Technology Challenge, 8 agencies were shortlisted, and we are using this technology in Chennai, and BG Shirke is doing the project. Okay, and already the project is more than 90% complete, and very soon that project will be handed over to the state level nodal agency. So this is about precast concrete construction, and this is the progress. You can see this beautiful photograph. This is the actual photograph from the site, and this photograph was taken, I think, a week back. Now the progress has gone much ahead. So see, you can see this entire work is almost over, and this is what is shown here, that they make these columns and beams, and that casting yard is just adjacent to the site where this casting of all these structural elements are taking place. Let's move to the next category. Next category is pre-engineered steel structural system and light gauge steel structural system, and this one we are using in 3 projects, namely in Agartala, we are using in Lucknow and Indore. So here, instead of cast in situ RCC column and beam, we have this factory made steel columns and beams. So these steel built up sections these are, and if you are interested, let me tell you that steel, normally we have hot rolled steel sections, okay, I sections or channel sections or angle sections, which are hot rolled, and those shapes are ISI mark shapes. But nowadays, with the advancement of manufacturing technology in steel, you can have built up section, and the moment we have gone for built up sections, it has opened ample opportunities to make use of steel structural section in building construction and other structures. So we get smaller built up sections, which can be rectangular sections, or which can be hollow sections, or which can be square sections. So these sections can act as beam and column. So these are manufactured in the factory and then brought to the site and erected to create a steel structural system or skeleton of a building, and then you can fill this by drywall construction. You can see this picture. So this is steel. This is again from one of the project site. So these are those steel, beam and columns, and then you have a slab, and then this is the wall, infill wall. In this, another category is light gauge steel structural system, so which is being used in Agartala in combination with steel structural system. So these are light gauge. This is a cold form steel. So the manufacturing of steel is here in cold form, whereas hot rolled steel is manufactured in where the steel is put in furnace and getting melted, and then we roll the steel in hot form. Here it is cold form through a machines, and also we have a lighter section, and then that steel is galvanized, so we get this corrosion resistant, free of corrosion galvanized steel, light gauge steel panels, which can act as wall as well as can be used for laying the floors. So this is that light gauge steel structural system which is being used in Agartala, and we have put shortlist 16 new agencies who are already working in the area of light gauge and steel structural system. The project which we are doing in Agartala is being done by where is that company? Yeah. So this is the company which is doing the Agartala project using steel and light gauge steel structural system. So this is that Agartala project I was talking about, and if you are able to see this portion in the bottom right hand side, you will see that this is that steel structural system. This is that steel structural system is used for skeleton, and then the walls are being made of light gauge panels, and that is a light gauge panel being used here. Now let's move to the next category. Next category is drywall construction, which is also known as sandwich panel system. And there are many varieties of sandwich panel systems now available in India. And just for the sake of clarity, where we have divided them into 2 categories. One is EPS 4 panel system. So what you see here on the right hand side, top portion, this is the EPS panel. So this white thing, what you see is expanded polystyrene. It's a thermocol of high density. If I have to tell you, casually, this is the EPS is expanded polystyrene. But for the sake of your understanding, this is thermocol of high density. So this is treated, and then you have a welded wire mesh. Then you can do the shotcreting, or you can do the plaster to create this kind of EPS core panel system. Otherwise, there are other kinds of panel systems which are available, which will have, instead of plaster, you can have fiber cement board, and the place in between the core can be lightweight concrete. It can be filled with rock wool or mineral wool. It can be filled with aerated concrete, or it can be a normal concrete. Okay, and depending upon the skin, they come with several names. Fiber, if you are using fiber cement board, then they are called fiber cement board sandwich panel system. Some agencies are using MGO board. Some agencies are using AAC panels. In the project in Agartala, we are using precast concrete panel, which will be cast at the site itself. So that light gauge, what I showed you, can be put with this kind of panels. So these panels You can see here. So this kind of wall, a traditional wall, brick wall, is being replaced by this drywall, which is made in the factory. And all these openings which you see here, whether it is ventilator or it is window or it is the door, they can be cut at the side easily with the help of equipments, okay, cutters and all. Otherwise, they can always be, they can also be cut in the factory and given in customized form to you. So this is that EPS panel system which I was talking about, and what that white thing is EPS panel. Our core is sandwiched between two welded wire mesh, galvanized welded wire mesh, and then you do the plastering or you can do the shortcutting. And this can be used as a staircase or as a slab, and you can do the plaster. You can put a fiberboard and all. Through Global Housing Technologies, 9 agencies were identified, shortlisted rather, I would say, and this technology we are using in Indore, and the company is Rising Japan Infra Private Limited. And they, as I told you, that these panels, depending upon the skin, the outer skin and the core, they are named accordingly. So they are using EPS cement sandwich panel system, which has calcium silicate board as outer skin, and in between they are filling it with elevated concrete, which is a special kind of lightweight concrete. And that is being used in Indore in a hybrid form along with steel structure system. It's shown here. So this is the lighthouse project at Indore where that technology is being used, that sandwich panel system. These are the sandwich panel system. Now imagine instead of you are replacing your brick wall or stone masonry construction by these kind of panels, EPS panels, cement EPS panels, which are manufactured in the factory, and then you just put them through a slide and lock arrangements to create your wall requiring no water, and it can be done pretty fast. This is that panel I was talking about of Rising Japan, which is being used in Indore. So what you see is this is that panel. So what you see here, this is the elevated concrete sandwiched between two calcium silicate boards. Next category is monolithic concrete construction, and this all of you must be knowing. This also known as aluminum formwork or Maivan. Maivan was the company which started this aluminum formwork in our country around 10 years back, and now we have more than 50 formwork manufacturers in our country. So this is a customized formwork instead of having the formwork of a steel or plywood and making the formwork separately for your beam, column, and slab. For the entire house or for the entire module, you can have the customized formwork of aluminum made, and then you can put the reinforcement cage in single pour. You can make the room or dwelling. So there were 9 companies or 9 agencies which were shortlisted Housing Technology Challenge, and those are given here. And the work which is we are doing a project in Rajkot, which is given to Autinad, where we are using a tunnel formwork system. So the difference between tunnel form and this kind of formwork is in this monolithic concrete construction, we have all the formwork for all the 4 walls, so we make the entire room. Whereas in that, this tunnel formwork come in form of L, so we make a slab and 2 walls. So we make a tunnel kind of thing, and the outer walls are later filled with AC blocks or any other filler material. Okay. I will show you the picture. Yes, so this is the one. The project is being done in Rajkot, and let me share with you the fastness of this technology. The entire one floor using this tunnel formwork, and this is the tunnel formwork. It comes in form of L. You can see here in this slide, the slide in the right hand side, the middle slide. So this is that formwork. So it comes in this form. So it creates the tunnel. So all these tunnels on one floor, 8 dwelling units are being cast in 3 days in Rajkot. So you can see yourself by visiting this project. So this is the tunnel formwork I was talking about. So it's an inverted L kind of thing. So you fix this formwork and create the tunnel kind of thing. And then later on, to create a room, you fill the outer walls with any kind of masonry. Okay, see the next system is the stay in place formwork system. Here the formwork is left in the structure or it stays with the structure. That is why it is called a stay in place formwork system. It is also known as sacrificial formwork or lost formwork system. And let me show you. Yeah, this is the picture. So this is that formwork we are talking about. So you put this formwork. It comes in form of blocks. These blocks are customized, made in the factory, and then you put these blocks in slide and lock arrangement to create this wall with openings cut and all, and then you can fill it with the concrete, do the plaster. So this acts first as a formwork, and then it acts as an insulation to your building. So that is why it is called insulating concrete formwork system or stay in place formwork system. We could shortlist 8 agencies with this stay in place formwork system, and this technology is being used in Lucknow, and the agency is Novel Assembler, who is using PVC stay in place formwork system. These are pre-finished wall. I will show you a slide. So these are pre-finished walls. It's like, buying a wall, pre-finished wall with it comes with different coloring option. So you can buy the wall from the factory or from the market and just, assemble it at or install it and decide to create a wall. Okay, so this is being used in Lucknow, and let me show you. This is the picture you see. So this is the PVC wall form, and it is being used in hybrid form because it's a high-rise structure. So it's a steel skeleton or beam and column, and the walls are of this PVC wall form. Yeah, this is the slide. So this is the PVC wall form I am talking about. So if you have difficulty in remembering stay in place, you can say pre-finished PVC wall or pre-finished walls. And you see, so the outer skins are of PVC, and these are cavities which can be filled with concrete or lightweight concrete, and you can put the reinforcement. As you can see here, the reinforcement bars are coming out of it, and you can create openings and all by cutting. You can put it with, you can fill it with concrete as per your requirement. Okay, and this is being used in the LHP project at Lucknow. So this was all about those 6 technologies I just mentioned, and pictorially I tried to explain you. In addition to this, the Government of India through Technology Submission is also facilitating and promoting. We are also handholding the state governments and their other technical agencies and development boards and other PWDs and other agencies engaged in construction of buildings and infrastructure. Andhra Pradesh, Chhattisgarh, and other, like Andhra Pradesh, we recommended monolithic, and several lakhs of houses are being constructed in Andhra Pradesh with monolithic, and now they are using precast also. So across all these states, we are promoting these technologies, and in case you require any kind of handholding or any other clarification, you can always write to the ministry or write to us, and we'll help you out in selection of the technologies. So the idea here is we have a basket of 54 technologies, and as per your requirement, as per your geoclimatic condition, as per the finances available with you, as per the time, you can choose one of them. And in order to create a suitable ecosystem for all these technologies, as I told you, all these technologies have already been approved by CPWD and Ministry of Housing and Urban Affairs, and schedule of it has SOR for most of these technologies has also been published in form of these. And around 1.6 million houses are being constructed across India using these technologies. Okay. So that is all for this. I just wanted to show you this slide. You can understand this. So all of you understand this level 0, and there are 4 or 5 levels of construction. And in India, we have this level 4. Level 4 is where you get the pre-finished, pre-finished, prefabricated house in the factory. All you have to do is you have to put it on the already laid foundation, connect it with the services. Services means electricity, water, and start using it. So that is called plug and play home. And in Ranchi, Magically is one of the agencies who is producing plug and play homes as well. So that is level 4. Level 3 is where you make these volumetric construction. You do and put them one block over the other to create the entire building stock being used in Ranchi. And then this is precast concrete construction. This is PV buildings. So our aim is to take a paradigm shift from level 0 to level 3 and level 4. So in times to come, let's forget about this, where we collect the material, procure the material at the site, get the formwork, get the labor and contractor, then do the, make the building, do the curing, do the finishing and all. And this time, instead of this, you make use of factory-made component and make the building within no time. So with this, let me end this first lecture, and now maybe we can start the next lecture. Manish.
Yes, sir. Sir, I think your voice is muted.
Sorry. So this was all about, the first lecture was all about the 54 new construction systems which we shortlisted and created a basket. And I tried to explain you pictorially those 6 broad categories. And if you really want to get into more details of these technologies, you can register yourself as Technograhi. We are also running a e-module on Technograhi, a certificate module. So you can take up that module by registering yourself as Technograhis and get access to all the lectures and technical details. You can also go to the YouTube channel of BMGPC, where you will get in audio-visual form the details about these technologies. So all the 6 technology, if you want to have deep dive, please visit Ministry's website or BMTPC website or go to our YouTube channel. You can also go to our website and download the certificates of all these technologies. You can also download the Delhi schedule of rates where detailed specification about these technologies are being given. And now let's move to the next lecture, which is specific to the technology we are using in Lighthouse project at Ranchi. And after this lecture, this is slightly technical in nature, so please bear with me because I just want to make you understand about the various nuances of this technology. And after that, we will have a virtual tour of the project site at Ranchi, and after that we will have question answers. So let me just share my screen, and if one of you can tell me if you are able to see my screen. If you are able to see my screen.
Yes, yes, it's visible.
Okay, so now let's move to this. And as I explained you, the category here is 3D volumetric construction. And now from my previous lecture, you can make out why we are calling it 3D volumetric modular construction. Okay, and the technology being used is 3D modular precast magic pot, which is the brand name given by the company Magicrete, who is executing this project. Okay. And why they are calling 3D? Because it's a complete room we are making, okay, instead of 2D parallel elements. And this, let me leave. Okay, this already explained you. And these are the details of those 6 lighthouse projects which we are doing. And today we are going to discuss this Ranchi project, which comprises of 1,008 dwelling units in G+8 configuration, with the project cost of 134 crore rupees. And let me tell you, this is the first of its kind application of 3D volumetric construction in our country at such a large scale. In G+8 configuration, 1,008 houses are being constructed for the first time in our country with this 3D volumetric construction. Just to give you the brief idea of the project site, so it has 7 blocks, what you can see here with red on the right hand side, 2, 3, 4, 5, 6, 7 blocks in G+8. So we have 9-story building. And for all these projects, please, I request you to mute your mic, please. Please mute your mic. You are disturbing others. So we are keeping a green space of 20% and ground coverage and all these things. FAR is as strictly as per the guidelines given by the Jharkhand government. Okay, and if you want to get into the details of the typical floor plans, so at each the floor we have 16 dwelling unit and we have a provision of staircases as well as lift, because it's a high-rise structure. So all the blocks are provided not only with the staircases but also with lifts. And at each floor we have 16 dwelling units. Let's have a look. So this is the 3D view of a dwelling unit, what we see on left hand side. So it comprises of 1 hall, 1 bedroom, a kitchen, WC and bath, and there is a balcony as well. So you can see here, this is a bedroom, this is a living room, bath, WC, kitchen, and balcony, and all these sizes confirm, sizes, width, height, all these things conform to NBC norms as well as the norms given by the state governments. Because National Building Code of India, for all of you who are civil engineers, architect, it is a Bible for all of us. If you want to decide about the space norms, other requirements, you need to refer in National Building Code. So National Building Code gives in detail the sizes, height, width of staircase, width of kitchen, minimum and maximum sizes are given in National Building Code for EWS and LIG category. So all these dwelling unit plans conform to NBC norms. And in addition to these things, we have also included other features because these are lighthouse projects and kind of modern projects. So all these projects need to have a minimum green rating of 3-star as per GRIHA. Use of renewable resources is being promoted or being advised, recommended in terms of rainwater harvesting and solar lighting. Solid waste management is also part and parcel of all the projects, all the lighthouse projects. Wastewater management, wastewater need to be treated and need to be reused for gardening and flushing purposes. All these lighthouse projects, because we have 1,000+ houses, all must have the sewage treatment plant and firefighting system, because these are high-rise structures conforming to NBC. Now, this is the technology. I think I have already explained you this, what you see on left-hand side. This is what we have, and this technology is being replaced by this kind of technology. It's a modern method of building, constructing a building where no longer you require structural elements to be cast at the site. Instead, you cast the entire module and then put one over the other. You can cast the entire room, or you can cast rooms separately, toilets separately, kitchen separately, and then put them together, connect them together to create your dwelling unit or a plant. Or a multi-story tower. And as you can see in this slide, on the right-hand side, these modules are transported to the site. Then on a foundation, they are assembled, erected, and then services also. And they will show you the services. You can either put in the casting yard, or you can put it at the site. It all depends. Here, the services, 70 to 80% of the work is being done in the casting yard and then brought to the site. So door openings and all you can create in the casting yard, and in fact you can put the windows and other things also. That's another level, the next level, where you can have pre-finished house. But in this project, we are creating the openings, we are putting the services and all in the casting yard, and then bringing it to the site, and then putting one over the other to create the entire building unit. Yeah, so now let me explain you the systems. First of all, any building comprises of superstructure and substructure. Substructure is the structure which is below the foundation and below the ground, and known as substructure. And the superstructure is whatever we have above ground. Okay, so that superstructure will be explained to you in terms of structural system, and it comprises of beam, column, structural system, and walling, and all those things. And foundation is that superstructure. So foundation, for all these projects, we are using conventional foundation. And conventional, if you are civil engineer or architect, you understand conventional foundations are of different types. It can be isolated footing, it can be combined footing, it can be raft, it can be pile foundation. Okay, so here we are using a raft because it's a 3D volumetric construction. So it was advised by the consultant that we should have a raft foundation here. And also in all these projects, we are not using customized foundations because soil strata in India varies from place to place. In fact, in all the 6 projects, soil strata is different. You may have a marshy land, like in Agartala, we have a marshy land. So there we have to have pile foundation. If you have a rocky terrain, you can have isolated footings kind of thing. If you have alluvial soil, you can go for raft or any other kind of footing or foundation. So it strictly depends on the geotechnical or soil investigation, bearing capacity, depth of the foundation is decided based on the soil strata and the water table. So here we are using a raft. I will explain you what does raft mean through a picture. So raft is basically a slab which is cast at the ground, and then from that the shear walls or columns are projected up to the plinth level, and at plinth level you can have a grade slab, and then start erecting these 3D modules. So what you see on the right hand side is that thing. So we have a raft, and over that raft, there's shear walls are being constructed, and these shear walls will terminate at the plinth, and then these walls will be filled. So we will come at the finished ground level, and at the finished ground level, these starter bars, these are the starter bars which will be left, and then these starter bars will be connected with the modules which will come over this shear walls. Okay, so we are using a raft foundation with RCC shear wall here. And structural system here, as I already explained you. So here we are not using beam columns, we are using the shear wall. So this is a 3D volumetric construction comprising of 4 shear walls. Okay, so this module is made in the cast or manufactured in the casting yard. Okay, so how they are done, we will show you through a virtual tour. So we have a steel mold, and then in that steel mold, you insert the reinforcement cage, and then you put the electrical and plumbing lines, and then you do the concreting, openings and all as per the drawings. You create the openings of door and windows, and then you do the casting. And after doing the casting, once the concrete gains the strength within maybe 2 days, 3 days, or 1 day, it depends the kind of admixtures we are using. We remove we demold and lift, we demold it and keep it for the curing. And when it attains a target strength, then it is transported to the site. So it's very simple. You have a mold, it's the reinforcement cage, do the concreting with services and all put in, and then get this module ready. So this is a structural system. So this is a 3D volumetric shear wall, you can say, which is being used as a structural system in this project. And these are these are pictures from the casting yard. So you can see what you see blue, this is the mold. Okay, so these molds are customized or tailor-made depending upon the size of your dwelling unit, size of your room or size of your toilet. These molds are being fabricated. So first foremost, the agency fabricates these molds, and then once you fabricate these molds, you put the reinforcement cage and do the molding and all those things. You can see here. So yeah, this is that thing, and now it is. You can see this is reinforcement is being put here, and then you will do the casting. What you see on the right hand side. Okay, and then after the casting, this is demolded, and this kind of volumetric thing you get. So what you see here on left hand picture, this is that from the casting yard 3D volumetric construction. Again, this is a picture. They are not only manufacturing here this 3D volumetric construction, they are also casting different kinds. They are casting pre-stressed. So these are the pre-stressed slabs which they are casting to have monolithic, to ensure monolithic behavior and to ensure structural integrity. The project is being done, and they are not only casting 3D volumetric modules, but they are also casting few shear walls as well as pre-stressed slabs. So this is the casting bed for the pre-stressed precast slab, and this is how it is being cut. You can see, like you cut a wood, you can cut this concrete slab. The advantages, let me not go into the advantages. All of you will agree with me that most of the work is being done in the casting yard. So it is pretty fast, and being fast track construction, you have resource optimization, improved quality, and finish is top class. There is no need. All you can do is you can directly paint it by putting some putty kind of thing. There is no need to do plaster at all. Okay, and also being a monolithic construction, because all the walls are being cast together, so it is excellent as far as disaster resilience or earthquake resistance is concerned. There is no wastage of material, and also wastage is minimized, dust free, pollution free. You are using optimally the water, because the entire thing is being done in the factory. You are completely eliminating shuttering and scaffolding material, and they are being replaced by these tower cranes and all, through which you lift these components. The essential requirement for this technology is this, and you can see you require a space, because casting yard is required to be established near the site. So you require a space. So here in the Ranchi project, the agency was provided with the casting yard space adjacent to the site, and in that space they have set up the casting yard, where they are casting all different kinds of structural elements, including this 3D volumetric modules. Okay, and then you know, you require a wide road so that through cranes and all, you require trailers through which you can you know, transport these the modules to the site. Okay, so approach road to the site, and then you require minimum widths of rooms and all, you know, roads and all, so that high capacity trailers and cranes can be moved freely there. And when we are doing this kind of heavy precast concrete construction work, you require a special set of skills. So skilled laborers are required, because hoisting, assembling, transporting to the site is a special require a special set of skill and require a special kind of people. So that is one limitation. But with the little training, the existing workforce can be trained for assembly, erection, and transportation. Okay, and another thing, you know, sometimes it is being asked that at a later stage, if we want to change the plumbing lines or MEP things, can it be done? The answer is no. Everything need to be planned beforehand. All openings, opening you can always close, but later on you cannot create the opening. Same thing happens with the electrical and plumbing lines. So all those things need to be pre-decided, because at a later stage it will be difficult to do, because the entire thing is being done in the factory, and breaking it later stage will, you know, affect the structural integrity of the project. Okay, quickly let me tell you also that all these lighthouse projects are awarded on a design build basis, and design build basis means we give the our specification, our requirement, along with the plot, and then agencies are asked to you know, design, asked to give their own design, and then build. And so that is called design build, or EPC contracting system. Through that system, these projects are awarded. And here we have SGC Magicrete, which is one of the pioneer agency in this 3D volumetric construction. They are also famous for producing this AAC blocks and AAC panels. So that is the agency who is doing this project, and I think they are also present right now in this webinar. Also, just for academic interest, I will show you when we are doing a design basis, design and build basis. So we have to strictly follow the design being you know, done by the company, by the agency, and then design is normally vetted. So in all these lighthouse projects, we are getting the design vetted by IITs. So the design given to us by this Magicrete or by the agency, we give that design to we ask agency only to get this vetted through IITs and all. So those designs are because being new technologies, we are getting this design vetted. And whenever we do the design, there is very important component is design basis report. Okay, all of you who are structural engineers, civil engineers now, with our country is being visited by earthquakes recurrently. Time and again we are having earthquakes, and it was found that most of the times when we get the sanctions of our houses, they are being done on a architectural drawing. So later on, design basis report was made a part of approval. In a state of Delhi or in Gujarat and other few states, design basis report need to be submitted along with your architectural plan to get the approval of urban local body. I don't know about Jharkhand. So design basis report is very important. So I will show you a few slides for design basis report, how design basis report is prepared. So for design basis report, you need to define what kind of structural system you are using, what kind of soil is there, what is the depth, and how you're designing it and all, and then what loads you are taking, depending upon the use. If it is a residential building and the load is 150 or 200 kg per centimeter square, in which wind zone the location falls, so accordingly you have to take wind loads. What is the earthquake zone? Is it a cyclone prone area? Then you have to account for cyclone loads. If it is a flood prone area, then you have to take storm surges, and annual rainfall is to be accounted for. So this is the wind zoning map of our country, and Ranchi falls in 39 meter per second wind zone, basic wind speed, and through this wind speed you can find out the wind forces for which building is to be designed. And the safe bearing capacity is 18 ton per meter square, which is quite high, and depth of the foundation is 2 meter here. The substructure, as I told you, is RCC raft foundation, and then we have up to plinth we have shear wall, and over that these 3D modules are being put. This is the earthquake zoning map of our country. Our country is divided into 4 zones: zone 2, 3, 4, and 5. Fortunately, Ranchi is in Ranchi we don't have any danger it's not an earthquake prone zone. It falls in the lowest. It is a low damage risk zone, having seismic MSK intensity less than 6. But despite of this, we need to incorporate, earthquake resisting features, because you don't know where the earthquake will come. So here, this is how earthquake force and base shear is being calculated. It comprises of a lot of things. I'm not going into the detail from this map. This is a seismic zoning map of our country, which is from Vulnerability Atlas of India, prepared by BMTPC. You can find out this Z. Z is the zoning. So because it is a low damage risk zone, so Z is 0.1 only. Okay, so that zoning map is multiplied, and then you multiplied with the weight to get the base shear, and that base shear is applied as a lateral force to design your building. Okay, and once you calculate the load, then you have to create a model in the computer. And nowadays, there are a number of softwares, CAD softwares are available, which will help you, analyze, create a model of your building. So this is the deep base aid structure modeled modeled through a software, and then it is subjected to so many load combinations. So this is a very evolved exercise to be taken up by a structural engineer. 13 load combinations for which the building is to be analyzed, and then for the worst possible load combination, the building is being designed. And when I tell you what design means, the size and shape of your wall, size and shape of your slab, all those things, the reinforcement requirement, what kind of reinforcement is required, what should be the percentage, what should be the spacing and diameter of the reinforcement. All these things are decided from the analysis and design. Okay, and thanks nowadays, thanks to the softwares available, now we have these many softwares, and all these softwares have incorporated Indian standards as well. So all you have to do is create a model, and then get the design done, and then produce the drawings in AutoCAD. Also, let me tell you, all these designs which we are doing, there are a lot of apprehension by people that these are new technologies and how they are going to fare in times to come, whether they are durable or not. Let me tell you, all these designs are based on two philosophies: limited state of collapse and limited state of serviceability. Limited state of collapse means in no event, in no time, building will collapse. Okay, during the service life, building will never collapse. There will not be any life-threatening collapse. There will not be any loss of life due to, and there will not be any collapse. So that is one limited state. Another limited state is serviceability. The building will, suppose the service life of building is 70 years, so building will remain serviceable during the entire life. So the design is based on these two premises. So if we keep strict quality control and quality assurance, we can always achieve this limited state of collapse and limited state of serviceability. Now the difficult part is over. I will show you the simple part now through pictures, the construction sequence. So this is the construction sequence. First you make the foundation, then and the side by side concurrently you are manufacturing those structural modules in the factory. Then you install on the already laid. As I told you, you come to the finished floor level. At the ground, and over that you have some starter bars, and then you have the bars there or in the modules. Those are connected, and these modules are erected. Okay, and here in this, what we are doing, we are making these modules without slabs. So once these modules are laid, then over that we put precast slabs. Okay, those are pre-stressed precast slabs, and some walls which are remaining, they are also being put here. So the idea here is to have structural integrity and monolithic action. Few like toilet pod and a room is being cast in 3D, and few things are cast as shear walls, 2D shear walls, and then a slab is cast separately, and all these things are positioned on the already laid floor, and then joined together to have a strict integral action. And then, while putting all the modules and while putting slab, what we do, we put a nominal reinforcement and do a structural screed is done over the pre-cast pre-stressed slab, so that all you understand, because our room dwelling unit consists of 2 rooms, bath, kitchen. So bath, kitchen, they are made separately. Then the corridor is made in a form of shear wall. All these things are, I will show you through a picture as well. So they are cast, then they are placed, and then slab is put, and over that slab screed is put with reinforcement, so that all of them are connected together. Okay, I think I have a slide which I will show you. So this is the structural drawing. I will not get into the detail. This just gives you an idea that this is the raft. So the entire, if this is the typical floor plan, so you have a raft of 700 meter, and what you see here are the shear walls. This is just a section. Shear wall. The shear walls have thickness of 160 mm, whereas raft is of 700 mm. This is another slide that we are using a high grade concrete because the elements are thinner in nature, so you need to use a higher grade of concrete. So for pre-stress, you all know for pre-stressing we require higher grade of, so M50 is being used. For structural screed, M35 is being used, and for all other the precast shear wall or precast pod elements, M30 concrete is being used. Okay, and all these grade M30, M50, and this thing mixed design is being done, and steel being used is TMT bar of Fe 500. Okay, and this is the mixed design. Let me also tell you, here we are using a slag cement, and slag cement is different than your ordinary Portland cement. And slag cement has supplementary cementitious material in form of slag. So slag is a byproduct of a steel plant. So that slag has pozzolanic property, so that can be added into the cement. Okay, so thereby just by utilizing that slag, which is a byproduct of waste, we are making the concrete green and sustainable. So this kind of mixed designs are being done, and it is again a good practice to have a mixed design so that you can optimally utilize different materials which are very precious, whether it is cement or water or aggregate or sand. And you see here we are also using fly ash. So 658 kg in M30, fly ash is being used. So that much of cement is being replaced by the fly ash. So that is again a good and sustainable practice. All these LHP sites have a batching plant, and all of you know batching plant. Instead of making the concrete, through other ways, batching plant will ensure resource efficiency and optimization of building materials because everything is automated through these silos, and all materials are being filled, and then automatically the inaccurate quantity, all the materials of this mixed design are being measured and then put in a feeder in a mixture to produce the concrete of desired quality and desired durability. Okay. Then this is now let's go to the foundation. So this was also explained to you into the film. So before getting the foundation ready, you have to excavate up to the depth of the foundation, then do the layout, and after the layout you have to put the PCC. PCC is a plain cement concrete which is normally of M10 grade. So PCC of 100 mm thickness is being put, and this PCC is normally being put because what you have is the ground of this kind which is undulating. So you have to have a plain surface. So for that PCC is being put. After that PCC, you put the reinforcement for the raft because we have a raft foundation. So this is the reinforcement for raft, and what you see, these vertical bars, these are the bars for shear walls. Wherever we have shear walls, these bars are being left vertically. So after laying this reinforcement for the raft, you lay the raft foundation, and then so this you see here. So this is that here the reinforcement was laid, then the concreting is being done on right hand side picture, and then this is the finished raft foundation for all the blocks with M30. This is a 700 mm thick raft, and now we will have a shear wall here. So shear wall, to cast this shear wall, we have to put the shuttering and then do the concreting. So this is the shuttering being put for the shear wall. So what you see in the bottom portion, that is the raft of 700 mm. Over that we have put the reinforcement is there. Then we'll put a further more additional reinforcement and do the concreting, remove this formwork to get the shear wall. So this is a closure look. So now this you see here, what you see, this is that shear wall of 160 mm thick, and now here this shuttering is being removed. So what you get is this kind of thing, and this is your plinth level or finished ground level. Over this, those volumetric 3D modules will come to create the entire floor with several 16 units. Okay, so this is the plinth framing plan. If you can see here, these are those pod elements. These are the position of those pod elements wherever pod elements will come, and these are the plinth beams. Okay, so all these at the ground level, at the plinth level, a plinth beam is being cast so that the entire floor is connected together. Okay, and then let me just not get into this. All these modules, when you are putting module together, how they are being, uh, jointed together. So there are different kinds of joints available. One is mechanical joint where you do the jointing through nut and bolts. There are emulative joints. Emulative joints are kind of joints which you have in your monolithic concrete, which you have in cast in situ RCC beam and frame. What you do there, you leave the reinforcement of beam and column, and then you do the casting at the sides to get the monolithic concrete construction. In a similar fashion, I'm not going into the details. These drawings you can always refer. What we are doing, we are leaving the dowel bars in different modules, and then those dowel bars are connected and then grouted through a sleeve and with a non-shrink grout. So you have it is kind of bars, steel bars. Okay. So those steel bars, of two modules are connected together, and then the grouting is being done so as to achieve monolithicity. Okay, so the different kind of joints, horizontal, vertical joints, L joints, all those joints are being designed together. And when you connect two, modules, then this kind of thing is being done with the screen and all. So I'm not going into those details. So this is the sleeve I was talking about. So this kind of starter bar is left, and then there is a bar from the upper this thing, and then they are connected through the base plate and all. Okay. Now just let me show you this. So what we have come up to the ground level, and once we have come up to the ground level with plinth beam and the grade slab, then these modules which are erected, which are cast in the factory, they are being erected here. So first stage is all these 3D modules are erected here. So first you have this, what you see in the uppermost left portion. This is that plinth beam and those grade slab I'm talking about. And now we are putting these kind of 3D modules here. So once we have put these 3D modules, the remaining places, we require a wall here, we require a wall here, we require a wall here, and we require a wall here. So these walls are also being cast in the casting yard, and they are being put here. Okay, so you put a wall here, and then to connect this, another element is being cast. So that element is also being put here. So first 3D volumes, then 2D planar elements in form of shear walls are being put. So this makes it ready. Now what we have to do is we have to connect all of them by putting a precast slab. So you see, this is the third stage. So now precast slabs are being put like this. Okay, so once you put this precast slabs, then you do the over this, you will put the reinforcement and do the screed concrete, so that the entire unit plan, the entire thing act in unison. And then once this is over, you will put again the same thing is being repeated. So let me show you again. This is the ground plan. Then over the ground plan, you are erecting those 3D modules, and then the left spaces are being filled with already precast walls. And then over these walls, you put this pre-stressed precast slab, and then you do the screeding, and then you start putting the other floor. Okay. So let me show you in the animation. So this is how it is being finished. Now let me show you in animation. Sorry. You see? So first 3D, then 2D elements, now other 2D elements which are remaining. So now this is ready for a floor. Now slab, pre-stressed slab is being put. And then you go to the next story, and like that you do. Okay. So I think this is understood. Now these are the actual picture, the progress being done. So you see how this you leave the shear keys. So these are the shear keys which are left in the structure during casting, and that's how it is being connected with the grade slab. So these are those 3D volumetric modules comprising of, basically it is a reinforced RCC shear wall of 160 mm, whatever thickness we have, with openings and services being put. And now this is being erected here like this. Okay, you can see it different. So like this, different modules are being put. You can see. So erection, this is again a picture of erection, how erection is being done. And when you do the erection, so you have to provide temporary, scaffold, temporary props. Okay, so these are special kind of temporary props so that this is not dislodged. Okay. You can see here. So these are the wall. This was that 3D precast, 3D precast element, and these are those shear wall elements. And what you see in the corner, these are that tongue and groove kind of thing, which is left, and then the shear key will come from the other side and to create a monolithic concrete construction. Then we have these starter walls. These starter walls will be inserted in this, and then you have a sleeve, and through that sleeve you will put a non-shrink down. These are those walls with troughs. You can see here. Another view, you can see. So that is all for this project. And what you see here are these starting bars which I was talking to you. So that is all about this project. And with this, now we will take you to the project site, and we will ask the technology provider to explain you the various activities being undertaken at project site. So Manish, if you are there, can you take them to the project site?
Sir, we are the live feed of Ranchi. It will take around 40 seconds.
Okay, so in the meantime, let me just explain you. So this process, what I explained you, is explained through these pictures. So first, we are putting these 3D volumes, and then okay.
Sir, in Ranchi, we have 4 cameras which are being set up, and all 4 are functional. And I think the control is with the Ranchi team. So I request whatever they want to show. Vitrang, are you there? Ranchi?
Yes, sir.
Okay. So why don't you start and explaining, one by one. You can control from there.
Yes, sir.
Okay.
No. This is Is our screen visible?
Are you sharing your screen?
Yes, sir.
Okay, all right. So we'll disconnect from your, and then you can share.
Yeah, sure.
स्क्रीन शेयर हो गया
शेयर नहीं हुआ।
शेयर कंटेंट को
Sheet.
Is our screen visible?
Yes, it's visible.
Okay. So this is the casting yard where we produce our 2D and 3D elements. For now, they have loaded some walls on the trailer for dispatch to the stockyard.
Can you make it full screen, Vitrang?
Yes.
So this is camera number 1, where the entire work of casting yard is visible.
Yes. So this is
All
the
right.
casting yard. These are the platform. These are the tables, and this is the pre-stress. This is the casting bed for the pre-stress slab, where we cast the pre-stress slab. On these tables, we cast the 2D walls. These are the 3D molds, where we cast our I mold and X mold. And this side also we have tables where we cast our 2D elements. These are the non-load bearing walls. Basically, these are the living room entry walls. So we'll install at the entry of the apartment. So from casting yard, we load the casted and cured elements on the trailer, and then we transport them to the stockyard and some of the element to directly to the erection location. So in this camera, you can see the 3D element is loaded on the trailer, and from here we will lift it and erect it. Here you will see the erection sequence. So they are lifting the element, lifted the element from the trailer, and now they will take it to its location.
So you are actually showing the lifting of unit.
Yes, lifting of this is the I section. After installation, it will create 2 bedrooms.
Okay.
Yes. So if you see this, you can see 2 windows here, one for each bedroom, and this is the separation wall. You can see now they are shifting. So from lifting to the installation of the element, the complete cycle is 20 to 30 minutes. So within 20 to 30 minutes, we install this element. So basically in 20 to 30 minutes, 2 bedrooms are ready.
Salesh sir, if you want to add something into it, Salesh sir.
Vikrang,
Yes, sir.
myself R.K. Gautam.
Sir,
You are saying around within 30 minutes 2 bedroom suite will be ready.
2 bedrooms.
सूट नहीं है सर, बेडरूम
Only 2 bedrooms.
2 bedrooms will be ready, na?
Yes, 2 bedrooms.
How many apartments are ready so far?
We have prepared 4 apartments for now, and we are now we have started
After
finishing
completing it, after completing it, you will show the all 4 bedrooms at site to me. Okay.
Okay, sir.
Can it be zoomed? थोड़ा और zoom कर सकते हो क्या?
हाँ सर. So now the element is at its position. Now they will check the dowel bars.
I think you selected the wrong camera.
No sir.
Same camera only. Because of internet issue.
Zoom in ज़्यादा हो गया. हाँ. हाँ. So here you can see these are the dowel bars. These are the dowel bars for the mechanical connection. We have couplers already inserted into the element. So those couplers will be aligned and inserted onto these dowel bars, and then we from inside we will do the non-shrink grout with the pressure pump, and that will create the final structural connection. So once now the element is there, now the team will be align the element and insert it onto the dowel bar. So this alignment is the time taking part. So this take 10 to 15 minutes to adjust it and insert it. So otherwise to lift the element and take it to the location, it hardly takes 5 to 10 minutes. So shall we go for the next activity? So as Shailesh sir has shown in the pictures, this is the live feed of building number 4, where we have casted, raft has already been casted, and the starters for shear walls are also casted. Now the shear wall reinforcement and shuttering is going on for the foundation. This is the next stage after shear wall. After completion of shear wall construction, we do the backfilling. and then we prepare the area for the grade slab. So this is the grade slab. This is the casted grade slab. We have done casting today, and this area is being prepared for the casting. So we have expansion joint in between two blocks. So till expansion joint, one area is casted. Now the second, the other part is being prepared. So reinforcement laying and shuttering work is going on.
Manishji, can you hear us? Manishji? Manishji, are you there?
Hello.
Yes, sir.
Yes, sir.
We are hearing. Nice.
Okay,
Okay,
fine,
sir.
fine.
Okay. So, sir, this is सर जो 4 अपार्टमेंट जो कंप्लीट हो गया है वो भी मैं दिखा देता हूँ.
Okay.
इसमें से visibility नहीं आ रहा है सर. These are the 4 flats which we have completed. So I'll share the pic. Just give me 2 minutes of time. Mail कर दे.
Sleep mail.
bus stand.
Yes, sir.
Take your time. You have to do it over there.
So can you see this image?
Yes, yes, yes. Go ahead.
Uh, this is the ground floor entry. This is our passage. So we have one apartment here, Then we come here. This is the bedroom. This is the I section. What we have shown. We have shown the installation. This is the I section, creating 2 bedrooms. One for this apartment and one for this apartment. And the next, these are another 2 apartments. This is the entry. This is the bedroom. This is living room. This is bathroom. This is kitchen.
यहाँ रोकूंगा थोड़ा, हमारा नंबर सिस्टम है, यहाँ पर नंबर जाएगा नहीं। हाँ बस इसी कह रहा हूँ मैं, 2 कदम आप चलना।
This is a staircase area where we will install the staircase. So the walls are installed and grouting is being done here. And this is the lift area where we will install the lift. So this is the lift shaft. We have 2 lift shafts. So these 4 apartments we have installed. Now we are doing the grouting. We have started finishing it. Yes, sir. Sir, any queries?
I think go ahead, go ahead. If you have shown everything, then fine.
Yes, sir. Yeah, we have shown everything.
Okay. Okay. Thank you then. So I think now with this, you have got the fair amount of idea what is being explained to you and what is being shown you through this virtual tour. And as you can see here, all the jointing is being done through those bars which he showed, and then there is a coupler and it's a kind of plastic sleeve, and then non-stick grout is being put so as to have a monolithic construction. Another thing which he wanted to show you is, depending upon the size of rooms and your plan layout, they have divided into few structural components. Few are the volumetric construction, then some are I section, some are shear walls and all, and then they are being placed here, and then over this precast slab will come, and then it's structural screed with that structural screed and reinforcement, everything will be connected at the roof level, and then the thing will be repeated. And that casting yard which they showed you is just adjacent to their site. So with this, I think If you have any questions to ask, you can just ask. You can write them in chat. I don't see any question. Uh, if you have any questions to ask, please do write in the chat box. Somebody is asking what is the difference between hot rolled and cold rolled steel. See, the main difference between hot and cold rolled steel is how they are processed. See, the process of both of them are different. Hot rolled steel is a classical conventional steel that has been rolled at high temperature. Okay, so the steel coils are melted in a furnace and then they are hot rolled through rollers. Okay, to get different kinds of shapes, I sections, angle sections, J sections, and all. Whereas cold rolled steel is essentially it's hot rolled steel only, but it is further processed in cold reduction mills. So you have a machine kind of thing where you have, hot rolled sheets, and through those cold rolled mills, you create these sections, okay, light gauge sections. Any other question? If there is any other question, we can.
Good afternoon, sir.
Yes. Yeah.
Sir, I'm Rohit calling from Devghar.
Okay.
Sir, I have a question regarding, sir, in this 3D volumetric construction.
Yes.
In RCC as a wall also, in wall also.
Yes. 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 Yes.
So we know that this thermal conductivity of RCC is almost twice that of normal brickwork.
Okay.
Sir, we have a problem in it that the heat and cooling cost of the entire building will be increased for entire life of the building. And moreover, it will add discomfort to the people living in it, because the heating of the exterior wall will be at double the rate of what it used to be in normal case. Are we doing something to prevent it?
Yeah, that's a very good question being asked by you. And let me tell you, first of all, your question is very valid. When we talk about reinforced concrete or thin concrete walls, there is a problem of thermal comfort. But here the walls are of, the thickness more than 150 mm. So that is number one. Secondly, the kind of, it depends on a lot of other passive measures which you adopt in your construction or in your layout and all. Where do you provide your openings and all? And majority of heat comes from from the slab, from the roof or the floor level. So here floor is also quite thick. But your question is still valid. So there is another concept of thermal mass. If you understand thermal mass, you will understand. See, concrete acts as a thermal mass, and thermal mass is a kind of barrier. It takes time to get heated, and it takes time to get cool. So that also adds to the thermal comfort. But your question is very valid. By increasing the thing, another thing is we are using a mixed, we are using a concrete which has slag, cement, and as well as fly ash. So that will add to the thermal comfort little bit slightly.
Sir,
okay, but still
sir,
your question is valid. Okay.
Sir, yes, sir. Actually, sir, I have worked for some time in Rajasthan. There we used My1 technology, and we did that concreting in walls also. But there also I was means I put forward my opinion that this particular technology of using concrete in walls is good at geographic locations where it is colder, like in Europe. It is very good. But in India, especially in western part of India, like Rajasthan, Gujarat, and MP, if we adopt using like EPS, means where insulation is provided between the walls to like to.
Yeah, it's okay. See,
My point, sir.
it's not the case. See, as I explained you, see, you have, outrightly you can't say 100 mm. Yeah, that's for sure that 100 mm wall is not good for thermal conductors. Okay, that is, but here we are making the entire structure with different openings and all those kinds of things. And as today in a building, majority of heat comes from the slab. So if you have a proper, treatment of your roof, majority of heat, you can get away with. Okay, you understand this? Okay, so irrespective, like in Andhra Pradesh, we have made several lakhs of houses with this technology. Your thing is valid, but when you are having 100 wall or something like that, then there might be a problem. But that problem can also be overcome by these passive measures which I suggested you. So just by this saying that the thermal it will be discomfort to the people will not hold the case. You understand? So you have to see holistically. Okay. Next
Okay,
question.
sir. Sir, can I come in, sir?
Yeah.
Thank
Yes,
you very much, sir,
Vikas
for
will
your.
tell you. Yeah, Vikas is doing in fact, yeah. Let me just add. Then you see. Sorry, I forgot. Yeah. Now under Indo-German program, we are conducting a study for all these lighthouse projects for thermal comfort. A special study is being done. Vikas is here. So ultimately, after we complete this project, we will have the data and we will be actually able to tell you the temperature difference and those things and what can be done for them. Okay, but now you can tell Vikas.
Yeah, this is a very great question, sir. And Rituraj, thank you for asking this. Actually, we are doing the whole analysis on all the LHPs, what is happening with respect to thermal comfort, energy efficiency, and sustainability. And in Ranchi, you can say that this is a type of monolithic construction, but it has been compensated with different passive design as well, like a mutual shading, which is a foremost thing. The second thing, what was done over here is a shading in the windows, proper shadings, 100% shadings, and then there's also input with respect to proper ventilation. If you have proper ventilation in Ranchi, then you won't be getting much heater sections in the wall itself. So these proper input through the passive design that has been taken care in Ranchi especially, and you won't find much of the discomfort with respect to occupant over here. So, but you're right, Rohit, that there could be some issue with respect to using monolithic construction in this type of area, not in the eastern part, but western part you do.
Any other question? Any other? Achha, there is a question. How can
I would like to add to this. Actually, while I am J.K. Prasad, while studying monolithic concrete construction, SEPT University has done a study where finally we found only difference of 1 degree from conventional to monolithic. So there are, as already explained, so many factors are there, and if you take care of all those factors, this thermal behavior can be very much controlled in monolithic also. So there should not be any problem.
Yeah, thank you, Prasad, for remembering. Yes, when Prasad was with us, the first technology in India which we promoted was monolithic concrete construction, this RCC shear wall. And in fact, this was the question asked to us time and again. So we asked SEPT University, what they did, they constructed a house using shear wall 100 and a brick masonry, 9 inches brick masonry structure. And they found a difference of, I don't remember, it was 0.5 or 1 degree. So there was a difference of only 1 degree Celsius. Okay. The next question, thank you, Prasad. Next question is, how can I get the training in physical mode? If you are a technograhi, absolutely no problem. As we told you that we have earmarked every 10th, 20th, and 30th of the month, you can go and visit. Our team out there will facilitate your visit and make you understand the various the technologies, their implementation, and things like that. Okay, so you can go. You are a technograhi, you can go there and visit the project. Absolutely, there is no problem. Okay. Any other question? Otherwise, you can always write your questions to us. Okay, we will try to respond to your questions. And with this, Manish, Vikas, shall we end up? Shall we end it or wait for some more questions? Manish, or otherwise, Vikas?
We are almost done. You can, Vikas, if you can say something, otherwise we can close, sir.
So there are no questions, then I invite Mr. Vikas. to propose vote of thanks. And after that, once Vikas completes his vote of thanks, may I request everyone to please switch on your cameras so that we can take a group photograph. It's a virtual group photograph with all of you.
Thank you very much, sir.
Manish, he's writing even to whom I have to communicate. So just email of this ESTC वाला mail जो है वो लिख दे जरा.
यहाँ से सकता है ना? Yeah. Hello.
Yeah. Please go ahead.
यहाँ तो आएगा ना? Network है इसमें?
Vikas, बोलो यार. Listening to you. Thank you, Manish. Vikas, go ahead.
ये तो आना चाहिए ना?
Vikas, we can hear you. Vikas, you are visible and we can hear you.
He's not able to hear you.
Not an issue, sir. You can just say something and then we'll wind up.
So I think we are not able to get Vikas. So on behalf of Ministry, so I welcomed you and I am also proposing vote of thanks. So I find my two young PMU officers here sitting, Sunil Parekh and Manish. So I obviously thank you for conducting this session and for bearing boring lecture with me. It was a technical lecture and you sat all through, listened to me. So thank you very much for a patient hearing. I also thank Gautamji, our director HF5, for giving us liberty to conduct this session. Also thanks to JS HFA, our mission director, also to Secretary Government of India for constant encouragement and giving us right advice. I also would like to thank Vikas, who initiated the entire concept of this webinar. Along with this, tomorrow he will be holding first of its kind physical training in Lighthouse Project Ranchi, where they will be talking in great detail about the thermal comfort and also my thanks to the entire Indo-German GIZ team, especially to Vikas Ranjan, and he has also stationed his teams at various LHP project sites created a cell, climate smart building cell. So I must thank, I find, officers of GIZ of CSFB cell present in this webinar. So I would like to thank them as well. So with this, we come to the end. In case we are not able to answer your questions, please do write to us and we will try to, address your issues and doubts. So thank you very much for being part of this webinar, and we will be conducting this webinar every week. So next we will go to either to Agartala or Chennai, and then we will repeat the webinars at all these places. So thank you very much. And if you all can switch on your cameras, Manish will take a beautiful photograph, a group photograph, all of you. And give a smile.
Can I see everyone?
Yes, sir.
Yes, sir.
I want all 81 participants who are available here. Thank you.
Thank you, sir.
Thank you, Rishi.
Thank you, sir. Thank you, Shailesh.
Thank you, sir. Thank you, Rishi.
Thank you. Bye.